Okay, this is going to be one of the last of the videos, I hope, that I have just on the desk like this. So after this I'm going to start hooking it up to robots. But I did want to take an opportunity to show you a couple of different ways to control the servos. I think in the previous video, or within the last two videos, I pulsed the servo manually to make it go. Okay, and I explained how it works. There's a library that's provided by Arduino that handles almost all this stuff like a black box. You install the library and you can make calls to it and everything sort of magically happens. And it's cool, and I'm going to show it to you. But there's also, you can actually roll your own sort of control, and I kind of like that. It lets you get right down to the nitty-gritty of what's actually happening, and it will behave a little bit differently. And a good friend and colleague of mine, Chris Odom, has written a really nice little module that I'll be posting that you can download if you choose, and we're going to go over it right now real quick. So here we go. I've got this piece of code written, and it's an awful lot of front-end work, and actually you'll see it on this and the Servo library. I've broken it down to a lot of front-end work. The first thing I've done here is I've declared pin 13 the onboard LED. Recall it's the one that flashes right here on the Teensy, and it's on pin 13. I've also set up two servos, the right servo and left servo, and I have them hooked up to pin 0 and pin 1. Okay, so the innermost wire is the white wire, the lightest wire. The outer is the ground, as I've explained earlier on. And I spent some time drawing, in fact there's a little drawing still down there, of these different pulses in microseconds. So 2000 microseconds is going to be the fastest that the left servo goes counterclockwise. And 1000 is going to be the fastest it goes clockwise. And since these robots are mounted with the servos sort of opposite each other, to make a robot go forward, one of them is going to have to go closer to 2000 and one of them is going to have to go closer to 1000. So the left is going to go 2000, the right is going to go 1000, and that makes both of the wheels turn the same direction on a mobile platform. But looking straight down on them, of course, you would see that they're spinning in the opposite direction. But we'll actually see that when we actually get them moving. So these are all my different ones. I would say this is where you're going to manipulate. If your robot veers off to the left, for example, all the time, you can't really make a wheel go faster than, for example, the 2000. So if it's going off in one direction, what you want to do is slow down the faster wheel. You probably, if you're already at max speed, you're not going to be able to speed it up. So you would end up slowing down, for example, this left one. If the robot was turning, for example, in this case to the right, the left wheel is going too fast. Well, I would slow down that left wheel. I'd maybe bring that down to 1800, 1750, 1900. You have to play with it and figure out which one makes your robot go straight. The same with these slow speeds. You'll notice they're closer to the 1500. Okay, so these are real close to that center point, and it makes the robot move more slowly. Tweaking, you're going to have to do it. Everybody does. No two motors are the exact same. Let's look at the setup. Okay, I'm going to have both my servos set to output. I'm going to have the LED output. I recommend doing this or something like it for all your mobile applications, unless it's competition. What this is going to do is it's going to flash the onboard LED 3 times over a course of 3 seconds, which gives you a couple of things. One, and this is not trivial, if the system is resetting for some reason, like too much current is being drawn or there's something shorting on it and the system resets, if it flashes more than 3 times, you know it's running setup and it's never making it into the main loop. If it just continues to flash, the processor is resetting. Okay, it's a great indicator. The other thing is it at least gives you 3 seconds. Of course, you can make this 4 or 5 or whatever many seconds you want, to essentially get your hands on the robot after you've pushed the upload button. So you've got a moment or two to switch on the motors, the power to the motors, get your thing lined up, whatever it is you need to do. It's a little bit of a delay. Diagnostic and delay. It's really handy. In this case, the loop contains only a little test. Okay, and that test is going to run these functions. These functions are in the module that Chris Odom has written. Okay, and if we look at it the way he's done this, the very bottom is the very basic stuff. Okay, create pulse. That's your most elemental one. You literally take and you set the pin high, whichever one the servo is hooked up to, for the duration of the pulse, and then it goes low. It does it just once. So if you need a train of these to make it go continuously, well, you have to do that. You have to create your own train of pulses. This is simply the command that actually handles it. If we go up one level, we see these are all single step functions. Okay? So for example, forward step fast, it's going to call the create pulse of both the left servo and the right servo, and it's going to pulse it for the duration that are specified in your constants up here. Okay? So it's going to pulse it for the fastest speed forward on the left wheel and the fastest speed forward on the right. All these other ones are very much related. They do the exact same thing. Okay, this one's calling slow, this one's calling backwards. Okay, these are all calling upon those constants that you've set up there and defined for your own robot. Again, it does it only once, right? And there's that 20 millisecond delay that you need to communicate. Okay, so it pulses once, 20 milliseconds. So if you want to continue to do it, you have to constantly call this. This one runs both wheels, this one runs only one. Okay. Now these functions are a little different. Okay. These will run a train of pulses, and the number of pulses is dependent on the argument which is put in here. So forward fast, if I put in 100, okay, it's going to load 100 into this for loop, and it's going to call upon the step function of move forward 100 times. So your robot will take 100 steps forward. All right. All of these are pretty much the same way. Right fast, left slow. They're all calling. You're passing the argument, and they're going to pulse it the number of times that the argument specifies. All right. So if we watch this run, and we go down here to what's actually going to happen, it's going to call this test setup. It's going to then enter an infinite loop, so it's only going to run one time. And it's going to go backwards, forward fast, forward slow, blah, blah, blah. Each one of these times, 75 times, 75 pulses. So let's let it go. I'm going to upload it. As soon as I see it upload, I'm going to then turn on the power to the motors. The light's still flashing, the 3 pulses, and there they go. There's your slow speeds. Okay, so that was 75 pulses each. Now, I've got about 6 minutes. I will post this so you can download this module. Again, I like it a lot because you have complete control. It's not a black box. Everything is laid out for you. You can create a tab. For those of you who don't know how to do that, you do that here. New tab. It's basically just another page. It's no different than putting it all on your one sketch. It just makes it a little easier to work with. Let's take a look at what happens if we call the Servo library. Okay, so this should come with your download, Servo.h. Okay, if I include that, that's going to give me the entire library server operation. all of this is still just as adjustable with the Servo library. In fact, I just copied and pasted it. These are all the exact same values that are on this other piece of code. Okay, so we should expect that to be the same. Setup, I've got pretty much the same thing. The difference here is instead of actually doing a manual pin mode output, in this particular case using the library, I have to do a left servo attach to pin 0 and a right servo attach to pin 1. This, and then I'm going to turn my LED, onboard LED, put it into output, and I'm going to flash it 3 times. So the only big difference is right here at this setup. These 2 lines of code are essentially the same thing as these 2 lines of code. Okay. So now let's go on down. I'm actually going to, this is going to be identical. Okay. Call test setup, and here's my test setup. However, it's going to behave quite a bit differently. What I've done here is I've created all the same function names. Okay. Notice though the argument in this case is not going to be the number of steps, but rather the duration of the time that the pulse train is going to be run. Okay. So in this case, it's not taking 75 steps. It's actually going to run for example, 75 milliseconds. And you're going to see a big difference when we run it. And this is what I mean by I don't quite have the same level of control. Here I'm going to set everything by time instead of actual steps. Let's load it up and see what happens. Again, keep in mind, I have these all identical to the other one. I just copied and pasted it. And let me turn that off so we don't get the processor reset. Okay, lights flashing, turning it on. There you go. A little quiver and then it kind of died. The reason is, actually the quivering and the death is a little unusual. Not the quivering isn't, but the death is. Like I said, it's not actually doing, for example, 75 pulses. It's doing it for only 75 milliseconds. I asked this thing to switch directions every 75 milliseconds, which is causing huge spikes in current draw. And since I'm running this thing tethered off of my USB, I probably simply saturated the current available and the system collapsed. Let's make these things a lot bigger so it actually has a chance to do it. So I'm going to, let's make it 275. So now they're going to run for 275 milliseconds, not 275 steps. Okay, my power is off on the servos. I'm going to upload it. I'm just holding it down so it doesn't move too obnoxiously. Okay, lights are flashing, power's on. See, even that actually caused the processor reset. Let's make these numbers much bigger. Let's make them 5. It really needs to be stabilized. So what I want to show you is what happens at the end, and right now my processor is resetting. Now that should be enough to let it stabilize the current draw. Lights are flashing, on goes the power. Okay, this is why I wanted to show you this. Is unlike the module that Chris wrote, this one is going to continue to run until you tell it to stop. Alright, oh, I've only got 30 seconds left, so let me end this video and I'll do a short follow-up and I'll see you in a few seconds.